Up until Christmas, every day, Eric Wastl releases 2 programming puzzles as part of the month-long challenge known as Advent of Code. And today, I'm going to be doing Advent of Code Day 9, and I've also done all the previous days and made video solutions for those. If you want to see those, there's a place to all of them down in the description. So I'm going to be continuing to do this. Today, we're going to be doing Day 9. If you want the code to my solutions, it's going to be in a GitHub repository, which is linked in the description. So let's dive right into Day 9. Day 9, encoding error. With your neighbor happily enjoying the video game, you turn your attention to an open data port on the little screen in the seat in front of you. Though the port is non-standard, you manage to connect it to your computer through the clever use of several paperclips. Upon connection, the port outputs a series of numbers, your puzzle input. The data appears to be encrypted with the Exchange Masking Addition System, XMAS, which, conveniently for you, is an old cipher with an important weakness. XMAS starts by transmitting a preamble of 25 numbers. After that, each number you receive should be the sum of any 2 of the 25 immediately previous numbers. The 2 numbers will have different values, and there might be more than one such pair. For example, suppose your preamble consists of the numbers 1 through 25 in a random order. To be valid, the next number must be the sum of those 2 of those numbers. Okay, so 26 would be valid, it would be 1 plus 25. 49 would also be valid, it is 24 plus 25. Okay, suppose the 26 number is 45, and the first number, no longer an option as it was more than 25 numbers ago, was 20. Now for the next number to be valid, there needs to be some pair of numbers among 1 to 29, 21 to 25, or 45 that would add up to it. Okay, and then it explains a few examples. Here is a larger example which only consists of the previous 5 numbers and has a preamble of length 5. Okay, in this example, after the 5-number preamble, almost every number is the sum of the 2 previous 5 numbers. The only number that does not follow this rule is 127. The first step of attacking the weakness in the XMAS data is to find the first number in the list after the preamble, which is not the sum of the 25 numbers of 2 of the 25 numbers before it. What is the first number that does not have this property? Okay, so this is pretty straightforward. I think we can just code it. There's probably doesn't look like there's any algorithms involved for part 1. So we're just going to be doing this. Okay, preamble length is 25. Okay, so there's 1,000 numbers. Okay, that doesn't look too difficult. So I think we're good on doing this. So let's just solve it real quick. Okay, so we got a really big number here. It's like something in its tens of millions, but let's see if it works. Okay, it's the right answer. So now I'm going to explain part 1. This part is pretty simple, I think. So basically what I did was I just wrote a function to, kind of wrap it just in case we have to reuse it or something. So this function is basically the whole program. The function takes in a sequence of numbers, which is the input to the XMAS program, and then it takes in a preamble length, just in case we want to generalize that. So what it does is it loops through the entire sequence, starting from the first number after the preamble, because that's where we're told to start, right? So after that, for every number in the sequence after the preamble, we look at the previous 25 numbers. So I'll just say 25 instead of preamble length. We looked at the previous 25 numbers, and then using a nested for loop, we look through every single pair of them, and if there is a pair that adds to our given number in the sequence, that means we found it, and it's not an invalid number. Otherwise, if we don't find any pair that sums to the current number, then we know that this number is invalid, and we can return that. So, yeah. Wait. Yes. Okay. And that's basically it. If we don't find any numbers that are invalid, return -1. That means the whole thing is valid. And then the rest of it is just parsing the input, which is pretty simple. Okay, so time for part 2. The final step in breaking the XMAS encryption relies on the invalid number you just found. You must find a contiguous set of at least 2 numbers in your list which sum to the invalid number from step 1. Okay. Again, consider the above example. In this list, adding up all the numbers from 15 through 40 produces the invalid number from step 127. Of course, the contiguous set of numbers in your actual list might be much longer. To find the encryption weakness, add together the smallest and largest number in this contiguous range. For example, these are 15 and 47 producing 62. What is the encryption weakness in your Xmas encrypted list of numbers? Okay, so we're going to solve this right now. Okay, we have our answer. Our answer is this number over here. So we're going to submit it. All right, it's the right answer. Okay, so now it's time to explain day 9. And I'll have some closing remarks at the end about what I think about the challenge so far. Okay, so first we're going to include the same function just so we can find the same number that we need. This is kind of redundant code. We could just use the same number, but I want this to be applicable for all inputs because everyone has a different input, mostly. So I just wanted to include this just so it's independent, you know? So we have this to find the invalid number that we need to do part 2 because, yeah. And then we need to find a contiguous set of at least 2 numbers that sums to our invalid number. And how we do this is we could do it naively, right? We could just like go through all, if you know something about time complexity, we could just go through all n squared pairs of start and end numbers and sum all of them. But that produces an n cubed algorithm. And in short, that means the program's going to run far too slowly and it's going to run in a matter of minutes, which is too slow for this video. So we need to find something that's faster. And how we do this is we use a technique that's actually commonly used in sort of competitive programming. And this is called prefix sums. I'll leave a link in the description to a resource that has more detail on prefix sums. But basically what prefix sums are is you take the sum of, let's say you want to find the sum of the numbers between the first, between 5 and 10, okay? So first we find, we pre-compute, we have pre-computed the sum of the first 10 numbers, and then we pre-compute the sum of the first 4 numbers. And if we subtract those, I should really have a diagram, but if we subtract those, if we subtract the sum of the first 4 numbers from the sum of the first 10 numbers, we get the sum of the numbers from 5 to 10. So you can just think about that for a bit, but it works. And the idea is that we just pre-compute the sum of the first n numbers for all the n, and then we can just compute the sum of all the numbers between one end, a starting point and an ending point really quickly. Yeah, and then we can just do the same thing as in the naive solution. We just do an nested for loop. We go through all possible start and end locations. This is represented by I and j. We go through all start and end positions. We find the sum using prefix sums, and this is our pre-computation. We compute the sum of the range. If the sum of the range is valid, it is equal to the invalid number, then we take the minimum and the maximum of that sequence, add them together, and then print it out. So yeah, that's it for part 2 explanation. If this helped you, please, I'm just glad it helped you. So yeah. Okay, now for some closing remarks. I haven't really done this, but looking at this map, it looks very strange. Like, I have a feeling something bad's coming up. Like, why are there these spaces in here? I don't understand. Like, I don't know. It's just very weird, and I have a feeling something bad's coming up because, like, normally this map represent. You can leave the video now if you don't care about this, but like, the map usually it represents something. So for example, in 2019, it represented a solar system, which is exactly what the puzzles were about. It was set in the solar system in space. In 2018, actually I don't know what 2018 was about. Oh yeah, some sort of time travel thing. I'm pretty sure 2017 was a computer. Yeah, 2017 was a computer. So yeah, how do I go to the okay, well I actually can't find it, but basically there's different years. This is my first year doing it for real. I did a few challenges from last year. Actually, I think maybe it's in the middle of this year. I don't know, but I didn't do very many challenges from last year. I did like 2. So, yeah. I don't know what this map is going to represent. This one's, I think, just about relaxing, because, like, in the past years, you saved Christmas many times, so this year's all about taking a break. I don't know what this map represents. I think this first part is just, like, traveling through the forest, because that was part of it, and then going to the airport, and then flying. So maybe that's why it's split up. It's, like, air travel. But yeah, I'm also kind of glad that, so apparently last year there was this thing called int code, and int code was a sort of program that you have to implement, and you have to, like, program your program to be able to run int code. That was, like, a different programming language, and apparently it appeared many times, and lots of people were a little bit upset about that, or, like, it was, yeah, not upset, but, like, it was just a thing. In day 8, they did something about that. They did some kind of program. So I'm glad that didn't appear again, because I don't know, that might have not been fun. But okay, that's basically it. Again, the code is in the GitHub repository, which is in the link to which is in the description, and also the playlist to all previous videos, and also a link to resources about prefix sums. That's basically it. So I think today was one of the more simple days, except for prefix sums, perhaps. So yeah, that's it. If you like this video and you want to see more, please make sure to subscribe and turn on notifications if you want to get notified for all future videos, because I will be doing all of them. And that's basically it. So I want to say thank you for watching, and I will see you tomorrow.